Hi friends, good evening everyone. Thanks for joining this session and welcome to the geospatial analysis or geospatial analytics session. This is one of the domain analytics program that we are conducting from 360DigiTMG in association with the Innodatatics organization. Based on various experiences that we have as part of our projects, exposure that we have, we try to bring in that knowledge, that experience for you people. And as part of today's session, we are trying to discuss about, as I said, geospatial analytics. Now, what exactly is the GIS data? What does GIS data mean? And how does this geospatial analytics actually helps? In what all various areas it can actually come into handy, approach? How is it handy in different applications? I will try and talk about some of the interesting use cases which we have seen, especially in the history. We have tried to understand various things. So we will try to bring up those use cases for our discussions here, right? And as I mentioned, right? So let's try and look at certain things, which becomes very interesting for us to look at the history of the analytics or geospatial analytics approach. Now, before I begin with geospatial analytics, we need to understand what exactly is GIS data. We'll talk about that. But even before that, what does this domain analytics actually mean? So if you look at the application of analytics itself, it's a study. I mean, it's been from ages there in the industry. It is basically a study, a field of study or evaluation in the trend that basically was trying to improve from hundreds of years now. So we have information to be extracted from the data. That's simply put analytics, right? And this analytics can also have different stages. And broadly, they are 4 stages. So understanding the past is generally done as part of descriptive analytics and diagnostic analytics. Right? It's basically something that we have been doing even before, right? Right from the pyramids, Greeks, when they were trying to, the pyramids that were being constructed. So it's basically a task, right? And there was a lot of data involved. So right from that stage, the analytics has been used, right, by humankind. And we're talking about the past information here, which we are trying to evaluate and come up with summary. It's more like a report, which will explain what happened. Ultimately, it will allow us to understand what was happening. So it gives us a lot of insights in the business case. This would definitely help in decision making. So we are talking about past here, descriptive and diagnostic analytics. But from there on, from that information, we will have to go ahead and also talk about predictive analytics. So looking at the past, we will be able to understand what happened and why something is happening. That's diagnostic analytics for us. When we combine these two, we would be getting a lot of insights in the business case. And we will be able to basically talk about the factors or the reasons which are influencing the outcome. So if we can play around with the factors, we can also try and understand how each factor is impacting the outcome, right? the relationship, basically. And if we can bring out this relationship, then using this relationship, we will also be able to do predictive analytics. Right? We'll also be able to do predictions, estimation on what may happen. And finally, with all this information, we would also be able to help the decision makers to come up with an appropriate plan that needs to be taken in a given business condition. Right, so that is about the prescriptive analytics. Right, so that's the 4 stages of analytics that we generally work on. Now, in order to implement the solutions here, we will be using something called as machine learning. Now, machine learning is basically a quantified approach which will allow us to use certain mathematical or you can say quantified techniques which can help us to derive the relationship. All right, so machine learning is a capacity of a computer program to learn and adapt to new data without the human involvement. We are basically talking about a training process, but not training a human being, but we are trying to train a machine so that it can figure out things just like how we humans do. That's machine learning. And in general terms, if I have to explain a machine learning concept, then it is basically a process of explaining a business case, explaining a business scenario onto mathematical form. You bring up a business case onto mathematical form. We call it as mathematical model. So in short, I would represent this as y is equals to f of x, where we say y is a function of x. Y is a single variable of interest. Variable of interest. Whereas this capital X that we are looking at is basically nothing but the factors which influence the output. Factors influencing the outcome. So these are all input variables, we can say in short. This is your output variable. This is your input variables, inputs. And we are trying to represent the relationship between them, the cause and effect relationship between these two, using a mathematical function. That's machine learning for us. Now, we will try and implement this on a geospatial data. Before I go to geospatial data, you need to understand what does GIS means in the first place. What is geospatial data? Right? Even before that, what is GIS? GIS is basically Geographic Information System. Basically, it is talking about data which is captured from geographical regions. That is, basically, it talks about locations. Okay. And this data is combined with the tools which can help us manage the data for extracting information. So in short, we are basically calling GIS as a detailed information about your Earth, right? Any location. I mean, if you're talking about Mars, trying to do some kind of analysis on planets or on specific planet on Mars, then it's basically the data or information about that particular location. So GIS is nothing but information or data about different locations. Okay, so geospatial data is data which basically talks about locations. It has originated way back in 1854. This is where the application actually have seen, right? I mean, was seen by the world. This was implemented in a outbreak, basically. It is epidemiologist. So pandemic kind of a scenario. There was a, I think, some issue. I think there were a lot of deaths which caused because of some water that is being consumed in UK. Some kind of corona or corolla, something, right? So there was some problem. Now it was not so easy to capture the information by which was basically right here. I mean, people were not able to identify what was the issue and all that. Okay, so this one person by name John Snow, this gentleman has actually used geospatial data in order to capture the actual cause of this outbreak. Right? This person's name is Dr. John Snow. Let me talk about this person's, this story. In 1854, right, and then way back in that year, 1854, there was this cholera outbreak, and there were different theories which came up, and there were a lot of deaths, especially in the in a specific district called in UK, London. So a lot of people try to bring up their theories and try to identify what is the issue and all that. But this one person, John Snow, he actually used the geospatial technique to track down the reason. So what did he do? Cholera outbreak. What he did is he tried to look at each residence, right? And he identified the residence where there was a death, right? Where a case was registered. And along with this, what was the water that these people were consuming, these residents, right, was consuming? So water body. These two locations were captured. Okay. So, but they actually used this kind of a visualization. A simple dot map was created to explain the results. So you can see there's a cluster. Right? There's a group of dots that you can see here. With respect to associated map, you can just Google for this. It's available. This image is available in Wikipedia as well. And you will see that the tap from where the water was consumed was marked as a star, and the house where the case was registered is marked as a dot. Okay, something on those lines. So the water that was consumed by is from a pump, you can say. Different pumps are there. And this water is basically provided by two different organizations. Okay. So this dot map helped in identifying the actual cause, and it was because of the homes which were consuming the water which was given by a specific company. They had issue. Because when investigation happened, it was observed that this company was using sewage polluted sections of water from Thames River. And only these cases, I mean, these houses were affected by cholera. And it was also measured that 14 times the chance of a case was registered from the houses that these waterworks company was supplying the water. So first company. Compared to another competitor company which was using fresh water. They were supplying fresh water. So the number of cases registered were almost zero. So it was clearly evident, right? So they were able to track the actual cause here. And this was considered to be one of the major breakthrough. Yes, no study was considered a major event in the history of public health and geography. And this is where people started realizing that the geospatial data becomes very important in various industries. Now, it is not just in this particular scenario. I will also talk about another example. Right? If you talk about the elections case, in elections, the geospatial data is heavily used. Okay, so for example, if you talk about the US elections, 2012, here also there is very interesting theories that came up, right? And this is one of the example of geospatial data. The scenario was very tricky in 2012, and Barack Obama has won the elections and he became the president, right? And it was basically explained as if this was more like a fluke and all that. There was no proper explanation, in fact. Many political experts tried to analyze the results, but their explanations were not decisive. It was very generic in nature when they were giving the examples. Right? Now, the actual results that we are seeing here is explained by another librarian. I think, he was a librarian. He came up with this geospatial analytics study for explaining these, the results. And when we talk about all these results, it was explained that there are these locations where, certain locations where there was no proper majority for any of these two, candidates. Now here, geospatial analytics was used by looking into the historical data and the pattern of all that information to come up with the solution, saying that this was basically very important information with respect to how the campaigns were done in these locations, right? And these are these few of the states, they actually decided the fate of the results. So there was a very clear explanation on how this geospatial analytics was used in the politics as well. Not just politics. You can basically go through the Wikipedia again to see all those information. But not just politics, but geospatial analysis can be used in various areas like pandemics I have talked about, politics we have talked about, defense heavily used, agriculture areas, yes, definitely very heavily used, disaster management, transportations, oil and gas, oceanography, right, real estate. So all these are different areas where we have the geospatial analytics being used. Now, one of these use cases, I'll talk about this scenario. Again, very, very popular information. Everybody knows, right? Canada is very geographically very vast. And they have a lot of forestry and rural areas. So the Canadian government, the Canadian Department of Forestry, they wanted to use a system, they want to develop a system which can actually capture all these information. I mean, all the data was required. So we have this CGIS. GIS is something that you already know by now, Geographic Information Systems. And we are speaking about Canada GIS. This system, which was developed by one of the team, I mean, it was in association with IBM, I remember that. So they developed this solution, and this system is basically used to track all the natural resources of Canada. What kind of land we have in the forestry, and then what are the different layers that we see, right? Every detail is captured here. Right, map scaling, then automatic gap closing, area measurements can be done by this, right? Map projections can be done this. So a lot of such details can be done, and there is a video also explaining what they have done. This was done by Canadian Film Board. You can search in Google, you'll be able to see that, and it's a very old documentary. 1960s, if I'm not mistaken. You can search for CGIS documentary. Right, let me try and show you that. I'll try to come up with CGIS here. I'll say CGIS documentary. I think YouTube. No, CGIS documentary. Canada documentary, YouTube. Yep, look at that. CGIS history captioned. Roger Tomlinson, he is considered to be the father of GIS. So this is a very detailed YouTube video. You can try and watch this, and it basically explains how the details were captured. All right, so very interesting. You might want to look into this video. Next, in order to capture this data, right? I mean, if I have to capture the GIS data, the first thing that I need is the data about the world, right? Earth. So that means I need to be able to capture the information about the geographical locations, isn't it? So we call this as remote sensing, right? I'm assuming majority of you know what is remote sensing. So remote sensing is basically the collection of the data, right? We collect the data about any specific object without contacting it remotely, right? Now, here the object that we are speaking about is about Earth, and we are trying to get the details about this object without touching it, right? So remote sensing, this basically has created a lot of advanced analytics or advanced development in the GIS area. It allowed a lot of research and development in GIS area. So when I talk about GIS or geospatial analytics, the logic is limited only for the geographic data. But if you understand the geographic data, getting the geographic data is biggest challenge. it involves a lot of ground to be covered, and it's going to cost a lot for doing that survey and all these things. The tools that we generally use for capturing the details from geographic location, geographic location perspective. Even if I use a GPS system, right? We use GPS system now, right? Which is basically getting the information from a satellite, in fact, right, into your mobile. So these techniques are very, very costly. They're resource heavy. Now, thanks to this remote sensing concept, it becomes very easy for us to get the data, right? So you basically will get the data automatically, in fact, and we will be able to extract the data from images and all that. Now, the first image that was captured from an aerial view was done using a hot air balloon. Those days, yeah, hot air balloons were used. Again, this is way back in 1850s. Right? A majority of the geospatial analytics started in 1800s. So again, 1800s, 1850. The first image was taken, and this was on Paris, in Paris, over Paris. Okay, and this actually gave a whole new perception and a lot of scope for geospatial analytics. This is called as aerial view or a bird's eye view. And as soon as this happened, post that. So this was in 1850s, and slowly the development took up, and around 1920s, a lot of aerial interpretations, aerial photography and all that has started. Yeah, in fact, in wars, Cold Wars, World War II. So in the wars, they use these spy planes, right? Even today we have these spy planes, which are basically running at a very, very high altitude, and they capture images, right? So it runs at a very, very high altitude where no weapon can actually track it or bring that down. But it has the system, high definition camera systems, which can actually capture all the various details from a aerial view, right? Aerial photography, basically. So this is basically from your analytics perspective. I mean, some basic explanations on what we can do, right? And slowly the visualizations, aerial view visualizations, moved into satellite imagery, and we had various satellites which were launched to get these aerial views. NASA, in fact, created satellites and tried to capture the data from right from the outer space. There were different systems which were used for capturing the data, right? And there's something called as different technologies were used, and RBV. It is called as RBV. We will be discussing about this anyways in the tomorrow's class. Return beam VDCon. This is nothing but a camera, which is video camera, which captures the details, right? And then it did not work. It did not went well. So then there was different logic or different science was used. I mean, different technique was used completely. It's called as MSS. RBV is a flop. RBV was a flop. So we had MSS that was used, which is called as multispectral scanner. And MSS is nothing but multispectral scanner. Right? This was a success. This was a failure. Return beam Vidicon, but this is a success, and there was no stopping back, looking back. It captured different images of the Earth's surface. The point is, when we are trying to capture these images right from the aerial view, then there is one specific challenge that we will see, that is with respect to the elevation of the data. Yeah. So how do you get this elevated data capture? That was a biggest challenge. Yeah. Because some terrains are very flat, some terrains are not so flat, right? So if we have to use the geospatial aerial view data, then the system has to literally capture the different layers, different levels. One such concept was basically talking about identifying the what do you call the burial grounds, you can talk about, right? So we basically have a lot of areas where I mean, prehistoric times, the people were basically, right, whoever was dying, they were using this locations, specific locations to bury them. But there's a lot of information that this, I mean, not just information to be precise, there are a lot of, I should say, artifacts, right? All these artifacts and all that, they come into the picture. So capturing this information, and I mean, a lot of thefts and all those things happen in order to capture the hidden treasure. Okay, ancient cultural sites, basically we call them. If you look at a ground, probably it is not easy for us to understand whether it was used as a ancient cultural sites. So when you talk about the aerial view and right, different geospatial analytics related concepts, if you capture the data from those scenes, then a lot of in-depth details we can capture, like discoloration, the land variations, right? What kind of vegetation does these have? Which areas floods are there? Which areas floods are not there? So all these kind of information can be very easily captured, right? So space archaeologists basically brought this concept, and they generally started looking into various right, maps, and then try to correlate various things to understand whether a specific location is any cultural site or not. Then people started looking into the digital maps, because now everything is digitalizing, right? But what kind of terrains does this land belong to, right? Whether this is located at subtle rises, or did the cultural site, that the site that we are speaking about is constructed on an elevated level, right? Just to ensure that floods are not right, affecting that area. Then we also used infrared and all those spectral imagery concepts to understand what kind of change was there in the vegetation, or maybe soil. The soil gets eroded, and then soil properties gets changed. over a period of time, right? So we try to understand all this information, right? And if there are anything which are buried under the ground in these kind of areas, probably it has to bubble up, right? It has to come to the surface. So when you look at all these information, there's some kind of pattern which can be captured, and using that pattern, we will be able to declare whether a specific site is ancient cultural site or not, right? And yeah, there's this specific case, right? When image data from satellites were analyzed, it was understood on what kind of area is molded, what kind of area is wetland, where you have water, all those things. And right, the problem with this is, if I as an ancient, I mean, as an archaeologist, space archaeologist to be specific, if you're trying to locate ancient sites, right, the problem is a lot of looting happens, right? It's a big threat. If you're trying to say that, hey, this location was an ancient site, which, right, our prehistoric people probably used, then I mean, these right, looters, they try to dig into the earth's crust and then try to find out if the some kind of remains are there, what kind of artifacts we can capture from this locations, because I mean, these are ancient material, right? So black market, there will be huge price for these kind of I mean, different jewelries, or could be anything. In black market, there will be a huge value for these kind of artifacts. So this is something that, yeah, you need to probably try and understand when I mean, these are all challenges, right? But you will be able to analyze the sites using your digital maps and images that we can capture from satellites, NASA images, you can see, right? And as we discussed, geospatial analytics is not restricted only to these few real estate or health or agriculture or defense related industries. It can be used in transportation, politics, oil and gas, right? All these areas. So as part of our sessions here, we will be looking at certain use cases for your geospatial analysis, right? And we'll also try and understand how the data can be stored. Okay, and the best example you can talk about is Google Earth, right? And because the data is really tricky, yeah, it's not straightforward that you'll work with this data, right? So you'll have to understand the logic of how this data can be captured, what is the schema and what are the standards. And we will try and understand the readily available data sets, which basically talk about spatial analysis. And then the use case that we will probably discuss is Openstreetmap, or you can also talk about the Google Earth Engine, GEE. These are a couple of use cases that we can probably look into. Right? I mean, Google Maps, if I talk about that in simple terms, we're speaking about Google Maps. Right? The GIS systems require huge storage space, right? Petabytes of data. And if you talk about Google, right, Earth Engine, that's the full form, GEE. It's nothing but Google Earth Engine. It basically contains images from satellites, right? And it is close to 100 petabytes of data, right? It contains remote sensing data and geospatial data, which is freely available, by the way. Okay, GEE is making the data public, right? But can I directly work on this huge data? Not really, right? It doesn't allow you to do that. Even if you take a single account will give you more than 200 GB data for processing. Yeah. So in order to deal with all this huge amount of data, you probably will require high infrastructure capability. And thanks to the cloud platforms, we have all that issues being taken care of, because cloud platforms will give you data which is, unlimited storage capacity, right? So the data that we can store is unlimited data, right? So that is something that you would probably do. And thanks to GeeMap or GE account, we will get all this publicly available data, and we can simply work with Jupyter notebooks. And simple Jupyter notebooks can be used for doing various transactions on that particular data. Okay, so that is one example. Then we also have, as I discussed, OpenStreetMap information, also called as OSM. OpenStreetMap. Again, this is also a geographic database, and it basically talks about the entire world, right? And this is also an open source. It's free to use. Okay, and you'll be able to look at buildings. Just like Google Maps, you'll be able to talk about schools, grocery stores, retail stores, that is, the buildings, commercial buildings, right, government buildings. All these kind of right information can be captured here in the OSM system. Okay, OpenStreetMap system. So that's about the examples of GIS. We will be looking at various solutions that we can try and learn on how the real world problems can be solved using geospatial analytics, right? And if I talk about the various other concepts, we will be literally doing the hands-on. Okay, what is the common data formats? How this data can be stored? How this data can be right, processed? If I talk about the data file formats, right? Ultimately, geospatial data is more like a geographic locations, right? Different geographic locations that we talk about. So here we can store the data in very simple CSV files or TSV files, right? Tab separated values, comma separated or tab separated values. We can also use photos, tagged photos, right? And we also have JSON files, XML files, database softwares, PostGRE database. This is one database which we will be looking into. Then we also have satellite and imagery data, aerial images. Then we also have something called as polygons, lines. So these are all different formats, basically, right? Each of these formats have their own pros and cons, and we'll have to choose the appropriate solution by doing the cost-based analysis on all these different file formats that we have. Next, we also try and look at how the geospatial data can be indexed. Right? These are very, very large data sets to start with. It is not like any operational data that we work with. Geospatial data is very large, right? And we're talking about gigabytes and petabytes of data. Okay. So whatever you do, these softwares that are tools that we are working on will be slow. Okay, that's something that we'll have to accept, because we're talking about gigabytes of data, and these are not simply organized in a table format. For quick indexing also, it's not easy. So these will be slow. Okay, that is something that we have to accept. This is also because we are trying to refer to the same data multiple times. Okay. Now, indexing here, I mean, just like any database, indexing here also is very important. That will allow us to quickly locate and get the required information from the entire database. Right? And we also talk about file structure. We also talk about metadata. There are certain standards for your geospatial data also, right? And metadata is basically information about the data, right? Data about data. The data formats that we're talking about, right? These basically are explained by certain standard formats. Okay, one is governed by right, federal units. We have something called as FGDC, if I'm not mistaken. It's something related to federal. G means geographic. Data. C is committee, if I'm not mistaken. Okay, federal geographic data. Okay, C content or committee. I cannot recollect that. Okay. We also have something called as digital geospatial metadata, DGM. Okay, and very important, there was another metadata requirements. This is created by European Union, right? And this is the newest one. It's called as INSPIRE. This is the full form, INSPIRE, infrastructure for spatial information, right, in the European community, European Union. Infrastructure for spatial information in the European community. Okay, so that is basically the standards. And as we talked about, the data that we are going to work with can be in right, it can be stored in different formats. It can be in an XML format or CSV format, or text files or binary files, or database software as well. We can also have data in XML, right, website imageries and all those things. And these are some of the standard formats of your data. We also have the advanced techniques which are used, right? And we can try and build Python models. We'll try and do that. This will help us to identify floods. It will also help us to identify crop health map. Because see, what happens is when we talk about crops, we're not talking about a small area. We are talking about very big area, right? Hundreds of acres, for example. Even if I have 10 acres as a single farmer, if I want to cultivate in the, right, this area, 10 acres, it will not be easy, right? Because the land would not be in a standard format, right? I mean, it would not be simple, straightforward, leveled. There will be different ups and downs in the land, and pest infestation could be there in one section. In one section, there could be a lot of waterlogging and all that. So thanks to the spatial analytics, we will be able to use drones to get the aerial view of the crops to understand the overall crop health, and you'll be able to manage it. right? So these kind of things. And anyways, we talked about Google Maps, which allows us to look at the street mappings and right terrain routings and high traffic locations and all that. So that's the basically the scenario that we would be looking at, right? And yeah, tracking vehicles is something that you can also do using the geospatial data. All right, so this is some of the use cases that we will be probably learning. We may not be able to learn everything, but something which is interesting and which is very important, we will try to cover that. All right, so that's about the geospatial analytics overview. And we are going to try and discuss analytical models which are used in geospatial data, GIS data. All right. So we'll talk about much interesting and fascinating examples, use cases on a daily basis. So keep watch out for the space, and tomorrow again we will connect and we will discuss about the applications part. Along with the application, we'll also try and bring in the analytical concepts which are specifically used in spatial analysis. Okay, all right. So with that, I will conclude for the evening, and we will be learning, as I said, interesting things as part of this domain analytics sessions. So thank you so much. Hope you have enjoyed the session. Hope you have got some insights on geospatial analytics. Thank you. Good evening, and we shall connect tomorrow. Thank you, friends.